Hello everybody. In this lecture video, we will see examples of the 7 types of exponent rules with their standard forms. Before we get into the rule table, what is power? Power is an expression of number with two variables, x and a. X is the base of the power and a is the exponent of the power. This means x gets multiplied 8 times, which you can say a factors of x. But there is a condition or restriction in power, which is x cannot be 0. This is because we cannot have different a factors of 0, which all have the same value, which is 0. For example, second power of 0 is 0 times 0, which is equal to 0. And we have 0 cubed, which is 0 times 0 times 0, that is equal to 0. We have two different power which indicates the same value. We cannot have 0 as a base. This rule applies the same in the exponent rule because we are using those rules to simplify the powers. So x and y cannot be 0 as each of those variable is the base from those standard forms. Let's look at the exponent rule in the table. First column shows the names of the rules, and second one is to show the standard or basic form of each rules. First rule is product rule. And when you have the same base, like a factors of x times b factors of x, then you can add the exponents together to simplify the power. For example, when we have 2 squared times 2 cubed, which is equals to 2 factor of 2 times 3 factors of 2, which is same as 5 factors of 2, that is 2 to the 5th power. But you don't really have to calculate it in this way. The product rule gives the same answer, 2 to the 5th power, with much simpler steps, or even you can do the mental math. Below is the power of product rule that I will explain here with an example, which sometimes get confused with the product rule. The key difference with these two rules is that they have either the same exponent values or base values. The next rule is the quotient rule. Quotient rule is just like product rule, except we change multiplication into division, and to simplify the powers, we need to subtract the second exponent from the first exponent. For example, say we have 5 factors of 5. This first example, 5 factors of 5 divided by 3 factors of 5, which is 5 multiplying 5 times, divided by 3 factors of 5, which is equals to 5 fives over 3 fives, and you can simplify those 3 fives on each side of the fraction, and that is equals to 5 squared. However, you can use the quotient rule to simplify the powers more effectively by subtracting the second exponent from the first one, which is 5 to the power of 5 minus 3, which is 5 squared. Again, they give the same answer. But using the quotient rule can save a lot of time. The rule below with x to the a power divided by y to the a power looks similar to the quotient rule, but this rule has the same exponent with different base values. For example, 3 squared divided by 2 squared, which equals to 3 times 3 over 2 times 2, that is equals to 9 over 4. However, using this rule here, you can calculate the value with simpler steps. This gets more handy when the numbers are bigger. For example, 100 squared over 10 squared, which is equals to, using the rule on the left side, 100 over 10 squared, that is equals to, after calculating the fraction inside the parenthesis first, then we get 10 squared, that is equals to 100. Another rule that you will see often is the power rule. When you have a number expressed power of power, then you can multiply the exponents to simplify it. Examples are like 3 factors of 2 squared, which is 2 factor of 2 times 2 times 2, which is same as 6 factors of 2, that is 2 to the 6th power. But again, you can find the exact same answer by simply multiplying those two exponents together, which you get the same answer again. Second example would be when we have 3 to the 4th power, power of 7th power, which you can simplify using the power rule by multiplying those two exponents together, and it'll be 3 to the 28th power. The power rule can be applied to the negative exponents as well. When we have 5 to the negative 1st power to the power of negative 7th power, then again, you multiply negative 1 and negative 7 together, which become 7, which is same as 5 to the 7th power.